Understanding dilutions. By the end of this tutorial, you should be able to solve calculations involving dilutions, apply the alligation method to dilutions calculations, and demonstrate how to highlight key elements of a scenario and a question. When a product is diluted, there is a change in the amount of product, although at the same time, the amount of ingredient remains the same. In pharmacy, a product may be supplied in a concentrated form. The pharmacist or the patient may have to dilute the product to produce a different strength. If the dilution is not correctly calculated, this could result in the patient receiving too much or too little of the active ingredient. Remember the 4 key principles. Number 1, read and understand the scenario. Number 2, read and understand the question. Number 3, highlight what the question is asking you to find out. And number 4, go back to the scenario, extract and highlight the information that is relevant to the question. Let's start off by reading the scenario. A prescription arrives in your dispensary for 30 grams of 6.5% weight per weight sulfur ointment. The only preparations available to you are stocks of 3% weight per weight sulfur ointment and 8% weight per weight sulfur ointment. How much of the 3% weight per weight sulfur ointment must be mixed with the 8% weight per weight sulfur ointment to fulfill this prescription? We need to start off by highlighting the relevant parts of the question. These are 3% and 8%. Within the scenario, we're going to highlight 30 grams and 6.5%, which is what we want our final concentration to be in, as well as 3% and 8%, which are our available strengths. Let's work out the answer. For this question, we are going to be using a method known as the noughts and crosses method of using alligation. You have to start off by drawing a grid. Something a little bit like this. Enter the values of your different strengths at the top corners of the grid and place the final concentration at the centre. So we're going to put a 3 and an 8 in the corners and 6.5 in the centre. Working diagonally from each top corner to the opposite bottom corner, calculate the difference between the two numbers and enter that number in the bottom corner. So we have 1.5 in one corner and 3.5 in another corner. Now you'll have to work vertically. So 1.5 represents the parts of 3% ointment required, and the 3.5 represents the parts of 8% ointment that's needed. If you add the total parts together, so we're going to add 1.5 of the 3% and 3.5 of the 8% together, this will give us a total of 5 parts. These 5 parts will represent the total quantity of the ointment. Now the scenario already mentioned that 30 grams is the total quantity required. So if 5 parts represents 30 grams, then 30 divided by 5 will give us an answer of 6 grams. This represents 1 part. So now that we know what 1 part is worth, we can work out what 1.5 part is worth and what 3.5 parts are worth. 1.5 parts times by 6 is 9 grams, and 3.5 parts times 6 grams is 21 grams. So we need 9 grams of the 3% ointment mixed with 21 grams of the 8% ointment to make 30 grams of a 6% ointment. And referring back to the question, it's asked us how much of the 3%, which is 9 grams, and how much of the 8%, which is 21 grams, have been mixed with the ointment to fulfill this prescription. Let's work through another question. So I'm going to start off by reading the scenario. A 69-year-old patient has been directed to dilute 10 ml of a concentrated solution of potassium permanganate to 400 ml and use the resulting 0.01% weight per volume solution to soak a gauze dressing and apply it to the skin for 10 minutes to treat a leg ulcer, twice a day for 10 days. You have Permitab's 400 mg tablets for cutaneous solution containing 400 mg potassium permanganate in each tablet. How many Permitabs will you use to make the concentrated potassium permanganate solution? Let's highlight the relevant parts of the question. In this case, we're just going to highlight how many Permitabs. From the scenario, we're going to highlight 10 ml, 400 ml, 0.01% weight per volume, twice a day for 10 days, and also 400 mg potassium permanganate. Let's work out the answer. So we already know that 10 ml of concentrated solution is diluted to 400 ml to create a 0.01% weight per volume solution. This has been diluted by a factor of 40. Therefore, we can calculate the percentage strength of the original concentrated solution. If we multiply 0.01% by 40, we get 0.4%. This is going to represent the original concentrated solution. Remember, percentages are always expressed as grams per 100 ml, so this is going to be equivalent to 0.4 grams in 100 ml. Now, we need to see how much of the concentrated solution the patient needs. He needs to use 10 ml twice a day for 10 days, so we're going to require a total quantity of 200 ml. We already know that 0.4 grams is present in 100 ml, so in 200 ml, we'll have 0.8 grams present. Permetabs contain 400 milligrams of potassium permanganate. If we divide this by 1,000, it will give us 0.4 grams. So one tablet contains 0.4 grams of potassium permanganate. To fulfill this particular prescription, the patient needs 0.8 grams of potassium permanganate, and this is equivalent to 2 tablets. If we go back to the question, it's asking us how many Permetabs we're going to need. The answer is 2.